I'm back. All right. Hey guys, we're back and we are going to be talking about the second part of section 3.1 now, which is dealing with domain. Technically, this is called implied domain. I don't know if that's what it's called in your book, but that's what we have it titled here. So there are three different cases when it comes to finding the domain of a function without looking at a graph or anything. And the three different cases are there's a variable in the denominator, a variable inside the square root, or it's just a polynomial, which means you don't have either of the above. So for case one, when there's a variable in the denominator, you are going to set the entire denominator to not equal 0 because we can't divide by 0, right? So you're going to set it to not equal 0 and then you're going to solve for the variable, and that's going to let you know what values of x it can't equal, and then we'll write our answer in interval notation. For a variable in a square root, we're going to set everything inside the square root to greater than or equal to 0, and then we're going to solve that because we cannot have negative numbers inside our square root, right? So that's why we have to do that. But if there's none of the above, so there are no variables in the denominator and there are no variables inside of a square root, then it's just a polynomial and your domain is automatically going to be all real numbers, or negative infinity to positive infinity. Now let's do this first example. We have f of x is equal to 5 plus 2x over x minus 4. When we go through and we look at our different cases, we see that there is a variable in the denominator. So we're going to use case 1. We're going to set the entire denominator to not equal 0, and we're going to solve for the variable. Now, a whole lot of times I get asked, there is an x in the numerator. What are we supposed to do with that? The answer is you don't have to do anything with that. That's not going to affect the domain at all. The only thing that we're worried about is this x minus 4 because we cannot divide by 0. Right? So let's go ahead and set this. So x minus 4 cannot equal 0. And now we're just going to solve it. And so we're going to add 4 to both sides. We see for this equation, we see x cannot equal 4. And the reason why this is because if we plug 4 back in, 4 minus 4 would give us 0. And once again, that's undefined like we learned in our last video. So now we need to write this in interval notation. It's every single value except for 4. So if we draw that on a number line, we see that we have 4 here, and 4 has to be an open circle, but we're going to shade everything to the right and everything to the left of 4. And so if we write that in interval notation, it's going to be negative infinity, comma 4, union, parentheses, 4, comma, infinity. So this is going to be our final answer for this problem. Our next example is g of t is equal to t plus 3 times the square root of t plus 4. If we go over and we look at our cases, we see that this one falls under case 2. There's a variable in the square root. Now you might be asking, what about this t that's added in front? Once again, that's not going to affect the domain at all. It's not going to cause any restrictions in the domain. So we're only worried about what's inside the radical. So we're going to say t plus 4 is greater than or equal to 0. And then we're going to solve. So we're going to subtract 4 on both sides. So we see that t is greater than or equal to negative 4. So we need to write this in interval notation. So to do that, we're going to put negative 4, comma, infinity. Except this time we're going to have a bracket around it because it is greater than or equal to. So this is our final answer. Our final problem is h of k is equal to 1/2 k squared plus 5k plus the square root of 3. Now this is got a whole lot of information in this problem, so we need to look through and we need to make sure and check our cases. So we go through, we say, is there a variable in the denominator? We do have a denominator, we have 2, but there's not a variable there. Right? We say, is there a variable in the square root? We have a square root with the square root of 3, but there's not a variable in there. So since it's none of the above, we're going to use case 3, which is a polynomial. And that means that your domain is all real numbers. So that's going to be negative infinity to positive infinity. So this is a brief introduction into finding the domain by looking at the equations. Our next video is going to be talking about the vertical line test and finding the domains from looking at the graph. See you then.